Perfect.
Thank you very much for introduction. And here is my pigeon, so we can start. And I will start by sharing my screen. Oops. And so do you see my screen?
Yes.
Perfect, thank you. So today I will talk about a tool for analysis of plumed output, or it's in principle possible. It's possible to use it for metadynamic simulation done by some different packages, but nowadays most of packages can communicate with plumed, which we developed in R programming language, and which you can use for analysis of your plumed output, for visualization of free energy surfaces, and for some other analysis. So I will start with some overview how we can analyze and visualize metadynamics output. So when I started to somehow play with metadynamics, I used, as probably all people that time, used some scripts, usually Python scripts for this purpose. Later, from I think it was since Plumed version 2, it became possible to use Plumed directly to some hills and do some other analysis. For visualization, again, you can use, for example, Python and Matplotlib or some other libraries. And again, different people use different like in-house solutions. And I was also using some kind of solutions like that. And my previous PhD student, Petr Hošek, when he started his PhD and he started to work with metadynamics, he asked me to give him some scripts or some programs which I used to visualize metadynamics output. And he was not very happy with this, what I wrote. So he decided to write something himself. And the result was Metadyn View, which you can use on this website. And it's a web application where you can upload your hills file. And then you can press the play button and you should see the evolution of the free energy surface. You can, of course, like change the time of the change the like different times in the progress of metadynamics. You can stop the this flooding or switch it on again, and you can also do some simple analysis. You can zoom in, you can click to certain points to measure free energy, or you can drag and drop from one point to another to measure the free energy difference. And you can export the result in SVG or PNG or some text file with the array of the result. The great advantage of this tool is that it's very fast. It's written in JavaScript, but it's very fast because it uses a very useful trick that instead of like calculating Gaussian function for every hill, like evaluating a Gaussian function, it calculates the Gaussian function only once, and then it uses this pre-calculated Gaussian to locate it to different points where these hills are located, and this is much faster. And a little bit later, because I am one of few people in our department who are working with some protein structures, bioinformatics, molecular modeling, I was asked by some colleagues to do some help with some expression data analysis. And at this occasion, I learned a little bit R, and I started to like it. And I use it for teaching, and I use it also for some analysis. And I developed Methane Miner, and a little bit later Methane Miner 3D. So it's a package where you can upload your hills file. You can convert hills to free energy surface estimate, and you can do some simple analysis. And the same you can done in 3D if you have 3 collective variables in a simulation, in metadynamic simulation. And Methane Miner also uses the same trick to make it faster. So we use pre-computed hills, which are being like just shifted and summed up instead of evaluating the Gaussian function in every step. Of course, you can use some special tools like last week you were presented the tool for setup and for analysis of the results of the funnel metadynamics. And there is some similar tool for bias exchange metadynamics, and possibly you would find some other specialized tools. So what is R? R is predominantly a package or program for data analysis. It's very popular in people doing statistics, people doing some bioinformatics, especially some expression data analysis and things like that. It's popular in social sciences, economics, and other fields. Honestly, if you think about like learning some programming language for your career in molecular sciences, if you are, for example, interested in some machine learning or things like that, definitely Python would be the programming language of choice. If you want to do something bigger like PLUMED, then you can learn C or C++ or some real programming language. And but I still believe that R, it's not so different from, for example, Python. So it's much easier to little bit switch in a syntax from Python to R and to do some simple task in R using Methane Miner rather than doing some analysis from scratch. You can download R, and this will be your first task from this website of our project, and at the same website there is a CRAN, which is a comprehensive R archive network, which is like a series of packages. There are something like almost 20,000 different packages available, like extensions for R, and 2 of them are Methane Miner and Methane Miner 3D. You can also read R journal, which is like a journal on different applications of R. Maybe you can think twice before you submit something to R journal, because we have submitted in August 2020, and it's still under review, but it's definitely good to read R journal. And there is something which is a little bit separated from this R project, and which is RStudio, and its graphical user interface. You can see a snapshot on the right side for R. So RStudio is developed by a company, and they provide this basic version of RStudio, fully functional, for free, and it's, as far as I know, also open source, and they provide some version with some support, user support, or some server version which is commercial. So if you like to use R and analyze metadynamics data on your laptop or on your desktop, then you can also install RStudio. For example, if you prefer, if you do some metadynamic simulation on some high performance computing clusters and grids, and you access it using Secure Shell, and you don't want to download all the hills files and analyze them on your laptop, it's maybe easier to use R without graphical user interface. This is also possible, and to do all this analysis on some server or on in some high performance computing center without any graphical user interface, and you can then just download images. This is also possible, and sometimes this may be more useful. I would mention some R extensions. So if people who are familiar with bioinformatics and especially some expression data analysis, they know some series of packages which is called bioconductor, and which is, as far as I know, maintained separately from this CRAN, these 20,000 packages. There are very popular packages for data analysis which are joined to some super package called tidyverse. So part of it is, for example, dplyr, which is used for analysis of some large data sets, or ggplot2 is most popular plotting package nowadays. I would mention two packages which are very useful, especially for some especially for reproducibility, and this is Knitter and R markdown. So for example, using R markdown, you can, instead of making some script in R, you can write some document where you add some functions in R, and then you convert this document into, for example, HTML file or PDF file, and it includes all the plots and all other with all the and some other outputs. So this is very useful for reproducibility, that it is recorded exactly what you did in the R session. And the last packages I would mention, there is Shiny, which is also produced by RStudio, and it is a package which makes it possible to prepare some kind of web presentation or web interactive application available on using internet. There are some machine learning packages, like Caret is very popular one. There are packages for different export and import of data. There are some special packages for some big data, really big data. If you cannot data you cannot handle in memory of the computer. There are special packages for spatial data, so you can use different maps of different countries, continents, counties, cities, and you can plot data or plot something on using these packages. There is a package called RCPP to use some C++ code in R, and also Methane Miner uses some part of the code written in C++ for acceleration. There are some special packages for parallelization, and there are packages which are used for helping with package development. So now, how you can use R? So as I mentioned, there are two different ways. The first option is to use RStudio, or there are also some other graphical user interfaces, but RStudio is the most popular one. So on your desktop, you can open RStudio and it will automatically load R, and you can use it, and you can use all advances of RStudio. Like there is a very good help, and it's quite easy to plot something and save it in some good resolution, and there are some other advantages. Beside this, you can use command line. So I mentioned this because sometimes it may be more useful if you have some big Hills files stored on some server, or Hills files from many simulations. You can write some script, and using this script, you can convert these Hills files to images and download just images instead of downloading Hills files. And if you can use, for example, in Linux, you can use R by typing command capital R. It will switch you to the R environment where you can do different commands. And if you want to quit it, then the function for this is Q with brackets, empty brackets. and it will ask you whether you want to save workspace image. And this is the same question you get if you close RStudio or some other R application. And I advise users to choose no, because if you choose yes, then this will save all your function you created during the run to some memory, and you will have them ready in your next application of R. But this may be tricky, that you can somehow fill the you can have some mess with some names of function and things like that. For scripting in R, you can write some R code into a script, and then you can execute it by one of these three ways. And I usually use the first one, so I'm not very experienced with the second and third way. And there is some difference, like in output. So this first one, it will print all the printed output on your screen, but you can, for example, save images and do things like that. So now how we can use R. So you can use R as some basic calculator. So you can do simple calculations in R. Here I would mention, if you type 5 divided by 2, R is not very strict in types of numbers, so the result would be 2.5. If you do the same, for example, in Python, you can get the result like 2, because these are two integers. But R is not very strict in this, so you can safely write 5 divided by 2, and the result is 2.5, not 2. So it ignores that these are like integers. This has some advantages and disadvantages, but it's quite easy to use. If you type some empty spaces, so if you type space 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 1 space 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 plus space 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 1 and enter, the result will be 2. And if you type so you can use as many spaces, and if you type 1 plus and then enter, R somehow recognizes that this command is not finished, or the expression is not finished. So it waits till you finish it. So if you type 1 plus and enter, the R changes the cursor or the beginning of line. And if you type 1 again, it's evaluated as 1 plus 1, and the result is 2. One more thing I would like to mention is this 1 in a square bracket. So this is like the index of the first number on the line. So if you work with some vectors and they cannot fit to single line, and they are printed on multiple lines. So on each line in a square bracket, you would see the index of the first element on that line. So now how we can use variables. We can save something to variables, and again, it's like good to use some neutral names of variables, not to use some names which can be somehow confused with some existing functions of R. So I use usually, either because my mother tongue is Czech language, so I use Czech language, or in the tutorial, I will not call it hills, but my hills. I will not call it free energy surface or FES, but my FES, and I will use this my prefix. And to save something to a variable, you can use this arrow. So it's like less than and then dash to make some kind of arrow. If you go to Google and you find some R codes, so there are quite many people who use normally equal sign, and it works equally well in most cases, but there are some exceptions where this can work not 100%. So I will be pure in this and I will use this arrow. In R, you can use vectors. So the simplest way how to make some vector is if you type 1:10, it will make a vector 1, 2, 3 to 10. or if you type 10 colon 1, it will write it in the opposite way. And if you want to get certain element, you can type the index of that element in square brackets, similar, for example, to Python, and this will return the element. There is one big difference from Python or C or C++ or Java or most other programming languages, that in R, these indexes start from 1, but in Python and many other programming languages, they start from 0. So for example, if you do this code in R and then you want element number 2, the output would be Garrett, because it's second in this vector, but in Python this would be Giovanni. In R we use, so the core of R is the use of different functions. So here it is demonstrated on function. For example, if you have function for sinus, there is just single argument. So you can, for example, make such a series of or some vector 1 to 100. If you divide all this number by 10, you got 0.1 to 10 with 0.1 increments, and you save it into variable x, and then you can calculate sinus for each element of x and store it into vector y, and then you can plot x versus y. Or if you want to set something more in the function, you can, for example, change that the type of plot will be not like points but lines, or you can change, for example, a range of y-axis from -2 to +2. So always like these different elements are separated by comma, and if there are some elements from which it is not easy to recognize what it means, then you have to like write that the name of element is equal to some value. If you need help in R, you can use either function help with the name of the function as argument, or you can use a simplified version like question mark and the name of the function. And what is important for making some visualization is how to plot. So there are basically two ways. The first one, definitely there are more different ways, but two most common. So if you use RStudio and use some plot function, it will you will get some plot in the RStudio graphical user interface, and then you can somehow save this plot, and during this saving you can also set a resolution and some size of image and things like that. Alternatively, you can use functions which are useful, for example, if you work in a command line, or they are useful if you want to make some large series of images. So you can use, for example, these functions PNG, JPEG, bitmap, and some others for either bitmap or vector formats. So you use a function, for example, PNG, and in bracket, you would write the file name, and it's also possible to specify other properties of the plot like size, resolution, size units, point size, and things like that. This will switch R into some environment in which these plots are not plotted on the screen, but they are plotted into the file. Then you can plot them using plot and some other plotting functions. And at the end, if you want to somehow like save the image, there is a command which you will see, which will somehow switch off the functionality of these commands, these functions. So this is a way how you can you will use it, for example, to make some movie, to plot series of images, or it is useful also to make images if you don't have graphical user interface. So if you are interested in Methane Miner, you can see some help either on the official website at CRAN. There is some, each package has some website, and there is some help, which is, I would say, a bit too formal. So here is some kind of like a more human readable help on this website, or you can find it on GitHub with the code. And of course, you can, if you find some problems or something like that, you can report them at GitHub. And if you replace here Methane Miner with Methane Miner 3D, you can find there the information also for this 3-dimensional version of the package. So how you can install it? So the basic command for installation of packages is this install.packages, and in brackets, in quotes, there is the name of the package. And I think for the first use, it will ask you from where you want to install it, because R has many different repositories around the world. So if you choose like the first choice, which is some cloud repository, it always works. If you experience some problems with installation, there could be some explanation in the tutorial itself, or feel free to contact me. I can help. For example, in Windows, you sometimes need some tool for compiling this C++ part, or there could be some problems with some access rights and things like that, but usually it's easy. So feel free to contact me if you have some problems. So this you need to do just once, and you can do it occasionally to check if there are some updates of the package, but you don't have to use it for every session. And what you have to do in every session, if you want to use Methane Miner, is to load it, to type the function is library, and in brackets is Methane Miner. Now it's without quotes, and this will load Methane Miner, and you can use it. This is usually the way that these packages are always have to be loaded, is probably because of some names of functions and names of variables to not to make some mess in use of R. So this command library and Methane Miner should have no output. So if you have no output, then it's installed properly. And you can read Hills file into the package or into R by the function called read Hills. It's necessary to specify the name of file. This file must be located in a working directory. If it's not located in working directory, you can either specify the full path to this file, or you have to change the working directory. This is also explained in the tutorial. And alternatively, if you want to download some file from internet, you can type here the internet address of the file. It is also possible. And at this point, if some of collective variables are periodic, you have to specify it. That's the only time you need to specify it, but it's necessary now. So for example, this is like a Hills file from simulation of alanine dipeptide in water, some molecular hero of many hour simulations. So there are two collective variables, two torsions, phi and psi. And because these are torsion angles, they are periodic. So you have to specify that the first torsion and the second torsion are both periodic. So this parameter is per and is equal to, then the C function is like kind of concatenate function. So it will join different elements into a vector, and T is for true. So this is like a logical value, true and true. So this means that the first collective variable and the second collective variable are both periodic. So this should, the output should be like that two-dimensional hills file was read into the R, and if you type again the name of this object, this hills file, it should write the same output, and it also prints how many lines it contains, how many hills. If you plot it, it will make some simple scatter plot, so it's not very illustrative, just for some checking that you loaded it properly. And if you do the same with just one dimensional, with just one CV, you should see like the evolution of the collective variable as a function of time. For well-tempered metadynamics, it's useful to plot the heights of hills. So that for this, there is function plot heights with the object of hills file as an argument. And the key is calculation of the free energy surface. And to do that, you can use one of two functions. There is function fes and function fes2. This first function uses this trick I was talking about, that it uses a pre-computed Gaussian hills, and it's therefore fast, but it may be a bit approximative. On the other hand, this fes2, it evaluates the Gaussian function for every hill, so it could be a bit more slower. So, for example, we advise users to use this fes if they want to just make some simple visualization to check how the progress of metadynamics, to compare some different settings. But if you want to make some publication quality pictures for like some final output final pictures, or if you want to make some more complicated calculations, or if you need some very high accuracy, then we advise to use this fes2 function. And in this function, you can specify the range of hills. So, for example, you can sum just first 100 or last 100 or certain range of hills. And it's possible to specify on what is the canvas, what is the range of collective variables on which it is calculated. And once you get this free energy surface object, you can add, subtract some constant, or you can multiply it or divide it by a constant. So, for example, if you want to convert from kilojoules to kcals, just simply divide by 4.18, or you can calculate minimum and maximum of the free energy surface. So using function min, you calculate the minimum, and if you subtract minimum from the free energy surface, you get the free energy surface where the global minimum is 0 and all values are positive. Or you can add or subtract two free energy surfaces. So, for example, if you calculate some free energy surface by one method and by another method, and you want to compare the result, you can subtract it, and you can see which parts of the free energy surface were maybe favored by one method and which were favored by the other method. So these are options, and of course you can plot it. So if you type plot and specify as an argument, you use the name of the free energy surface variable, it will make such a plot. You can specify different ranges. You can specify, you can add here title, or you can change titles of axis. You can add here a color scale for the free energy, and you can change between types. So you can have either like this just color map without these contours, or you can have just contours, or you can have both, combination of both. For colors, I will show here that when I submitted this package to CRAN, this is evaluated partially automatically and partially like manually by CRAN curators. And I was standing in a queue, or this package was standing in a queue for this evaluation with other packages. And I mentioned that there was a package called Harry Potter. So I was thinking like, what could be the package called Harry Potter? And I found that somebody developed a package that he somehow extracted colors from Harry Potter movie, which are characteristic for certain character of the movie. And then these colors were converted to a color scale. So if you are not happy with this color scale, which I use in Methane Miner, so it's basically like a rainbow from which I removed violet color because I didn't like it. So if you want some different color scale, you can use, for example, Harry Potter, and 100 means that there are 100 colors or 100 different colors from the minimum to maximum. So there are many different options. It is also useful to identify free energy minima on the free energy surface. And if you, in many metadynamic simulations, especially if you use some narrow hills, you can have a huge number of free energy minima. And it's usually not very useful to identify all of them. So for this purpose, we developed some function which is called FES minima, and it somehow separates this free energy surface into, by default, 8x8 grid of sectors. Then it calculates the minimum for each sector, and then it tests whether this minimum is local minimum of the whole free energy surface or not. And if it is minimum, it is if it is identified as this minimum, and then they are sorted from the global minimum to on the free energy. So in this case, it is A, B, C, D, E. And if it's not, it's simply discarded. So for example, some point here is the minimum of this sector, but then it goes downward this way. So it's not local minimum of the whole free energy surface. So it's discarded. So this is quite simple way how to identify some representative free energy minima, and you can somehow limit their number to some reasonable number, and you get like kind of reasonable distribution on the whole free energy surface. It is possible to change, instead of 8x8, you can change the number of these grid points. And if you identify minima, you can calculate like the evolution of the free energy, like one minimum subtracted from the global minimum. This is calculated just for these points. So for example, if you have minimum A and minimum B, then minimum A is always 0 in this plot, which I have shown on this next slide. And minimum B is like this difference, like A is 0 because it's A minus A, but this B is B minus A, and it may fluctuate, but it's only calculated like free energy at this point, or the sum of bias, negative sum of bias potential at this point, minus negative sum of bias potential of this point at different stages of the simulation. It's not calculated by some summing of probabilities in the whole minimum. We are working on something similar, but it's still in progress. So maybe in future we will introduce this into Methane Miner, but now it's still just a point versus point. But this can be useful to evaluate the convergence of the free energy profile. It must be kept in mind that this is, like I would say, one of signatures of Convergence, but not only signature. So I would advise you to, for example, go to the masterclass on analysis of metadynamics output in terms of statistics, in statistical analysis of metadynamics output, and by Gareth Tribello, where you can find more details. In future, we plan to introduce something more sophisticated to get some error bars and to get some more statistics. But at the point now, it's just this point versus point difference calculation. You can plot it, and you can also like make the summary, which will, for example, if you decide to do this calculation on last 10,000 hills, it will calculate the minimum and maximum in this range. And finally, there is an option to run a nudged elastic border. So you can choose two minima, for example, A and D, and you can, and the function will find the most favorable path from A to D, and you can get either this profile or this profile, and you can predict some kinetics, but of course, like, it must be kept in mind that kinetics, evaluation of kinetics by metadynamics is a bit like you can do it for only dipeptide, but for some complicated system, it's also a complicated task. So this is all for introduction to Methane Miner. I would also mention Methane Miner 3D, which is very similar, but of course you have to visualize something in 3D, so you can get such a three-dimensional bias potential, three-dimensional free energy surface, where this is plotted as isosurfaces at certain value of free energy. So this is alanine dipeptide in torsion phi, psi, and omega. And advantage is that you can, in R, you can rotate these and zoom in and do some zoom in and rotate. And it's also possible to export it to some JavaScript app where you can save it as a website, and user can also zoom it and rotate it. So this is quite useful. I would mention some playing with Methane Miner. I have already mentioned like a Harry Potter color scale for your free energy surface. So I have here a free energy surface, which you can see also in a picture, which was printed on a 3D printer. And it was very easy because there is a library or some package for R called Ray Shader, which is used to plot or to print some objects from R on 3D printer. So using just these commands, you can export this free energy surface as STL file, which is just like a standard for 3D printing. And this STL file have to be converted to the file which is used by the 3D printer. And this is all usually, as far as I know, I'm a big expert in 3D printing, but as far as I know, this step is somehow dependent on the 3D printer, so it cannot be done universally, but this just like 1, 2, 3, 4, 5, 6, 7, 8 lines of codes can be used to just make such a 3D printed 3D print. So now, what would be your exercise? So the first part of the exercise is that you have to install R, and if you wish, you can install also RStudio. There are instructions there are not direct instructions, but there are links to different websites where you can find all these codes and where you can install everything. The next task will be to make that there is a simple R quiz on the next slide. So I will show you on the next slide, or I will also put it on Slack. I'm not sure if there is some link to the document or to Google form where you can apply for joining Slack. So I would maybe ask if I will check it later before we finish. I would ask maybe Max or Giovanni to add this link to this form. So you can. I will also put this R quiz to Slack, and I will give you correct answers, not next Monday, but somewhere in the meantime. So this is just to show whether you installed R and RStudio successfully. And then you have to install Methane Miner, and you can load hills from 10 nanosecond metadynamic simulation of alanine dipeptide with two collective variables, phi and psi. So very simple calculation. If you like to run this calculation yourself, there are all data available, but you can use just this hills file. In the next step, you will calculate the free energy surface and plot it in high resolution. So you can use different options either in RStudio or using this special function for plotting in R without RStudio or without just in command line, what you prefer. Next, we will convert this one-dimensional, this two-dimensional free energy surface into one-dimensional, and so we will get a one-dimensional free energy surface of with a phi CV, and because it's from 10 nanosecond metadynamics and because it's alanine dipeptide, we can at the moment use it as a kind of ground truth, some correct free energy surface. And next, you will load hills from metadynamics, which is just 1 nanosecond, and which uses just one CV, which is phi angle. And your task will be to somehow visualize, preferentially animate the flooding of this ground truth one-dimensional free energy surface from 10 nanosecond metadynamics by this bias potential from this shorter 1 nanosecond metadynamics. And your task will be to evaluate whether the metadynamics with just single phi collective variable works well, or there is some hysteresis, and if there is some hysteresis, how big is this hysteresis? And finally, we can do something similar with metadynamics, which uses psi, another collective variable, as the only corrective variable. And because it's not possible directly to calculate just simply by summing hills, to take metadynamics in psi collective variable and calculate the free energy surface in phi collective variable. For this purpose, we have to use reweighting. And in the tutorial, there are some explanation how this can be done. And this reweighting goes a little bit beyond some basic use of Methane Miner, because what I have shown so far, we were using some objects, like for example, free energy surface, but it's also possible to like go to this object and take some instances from this object. For example, the free energy surface itself, like only this free energy surface as a raw matrix. And in this reweighting part, you will use these little bit advanced options. So this will demonstrate how you can use Methane Miner for some more complicated analysis. So this will be your task. You can, of course, use, if you have own interesting metadynamics results, you can try to analyze them. If you find some problems or you find some hints, what should I include in Methane Miner, I will be open to any any input. And now I can give you the quiz. We have 5 minutes left. So the quiz is this one. It's our quiz, and your task will be to name the movie based on R command. So there are like 3 R commands. This is like 2 R commands, but take it just as one. So there will be, you should name 3 different movies based on these R commands. So this is this task that I will give you correct answer in some not next Monday, but a little bit earlier on Slack, and the rest we can see each other on next Monday, and we can discuss the solution, and we can share some experience, and I would be very happy to help if you have some your data and you want to analyze them, or you want to you would prefer some different function in Methane Miner, or you have some hints what to improve. So I will put this quiz on Slack, and thank you very much for your attention, and I will try to stop sharing my screen at the moment. And unfortunately I cannot see your yours. Yeah, I have some problems with Zoom, so I guess you do not see my screen. So I would try to put in a chat here is the link for joining joining Slack. So thank you very much, and we will see each other on Slack. Are there any questions? I hope that all the...
Hello.
Yes.
Hi. Thank you for the great talk. It was as a person who used metadynamics a lot, it was very refreshing to see a new tool come out for metadynamics. So actually, I had one question. Could you go to the NEB slide once? The NEB slide that you had shown for the hills one that you developed?
I'm not sure I understand the question.
The nudged elastic band method, the nudged elastic band slide that you had shown for your
yeah.
So I had a particular question. So the input to your Methane Miner analysis tool is only the hills file, and you have generated a free energy surface from that, right? And you have specified 2 minimas from which to start NEB. But the NEB algorithm has no idea of the system, right? It has no idea of your alanine dipeptide structure. So is the NEB run on this 2D, assuming that this is a 2D free energy surface, and then it has run NEB on that?
It is calculated just on this this 2-dimensional free energy surface. Yeah, you are right. It does not take into the account the structure. It's not like a nudged elastic band, which is used in some quantum chemistry packages to get some mechanism of some chemical reaction, for example. This is simply just to find the most favorite path from one minimum to the second minimum based on this free energy profile. So yeah, you are right. It's just it is simple driven on this 2-dimensional free energy surface.
Thank you. A follow-up question. So if I were to take these points A and D and find structures in the trajectory which are closest to these points and run NEB, nudge elastic band from some simulation package, would that be considered a correct approach? Because another question I have is that this simulation, the metadynamic simulation, is biased, right? So any structure that you report from the metadynamic simulation, would that be considered quote unquote sample from the equilibrium distribution? It's not, but is it okay to take it as an initial structure and run an inelastic band simulations on it?
You mean nudged elastic band in some different package, like on a full coordinates and the full
Yes.
potential
Yes.
energy?
Yeah.
So this is difficult question. I'm not big expert in this. Is like a lot of do with kinetics and mechanisms and these things. So I cannot. Yeah.
Okay. Let me just.
I introduced this nudge elastic band just to make some nice and energetically favorite pass from one point to another just on this free energy surface. So it can be used for some you can estimate the free energy barrier, and if you have some very simple system like alanine dipeptide, or you have some very good sampling by metadynamics, or you have some very good collective variable possibly, then you can use it to estimate kinetics quite well. Of course, if you have some complicated systems, some imperfect collective variable, then this is very difficult to calculate like kinetics from this, just from this two-dimensional profile. And there are some tools for this, like infrequent metadynamics is very popular, was also mentioned in last week tutorial, and I think there will be some applications of infrequent metadynamics also in the next series of master classes. So I'm not a good person to give advice on kinetics by metadynamics. This is something there are many. I know many people who are much more much better in this field.
Thanks for your answer. But actually, I'll reduce my question to this, right? Can we use structures from the metadynamics trajectory to report conformational changes? So if you have your minima A and your minima D, and you you find a structure in minima D from your trajectory, can you report conformational changes using the trajectory you obtained from metadynamics? That's my question.
So unfortunately, it is not connected to some, like it would be quite nice to connect it to some structure viewer, which is not the case. And I was asked by some user to, which will be quite easy, just to, if you have some minimum, that it would be possible to find some nearest simulation snapshot. So then it would be easier, for example, in VMD, just to change the snapshot number and to see some snapshots associated with certain minimum, or for example extract from the trajectory only those several representative structures for each minimum. And unfortunately I haven't introduced it yet to the package, so this is on my to-do list. Sorry for that. So if there is a demand for this purpose, which is for this function, which could be very useful indeed, there will be one more motivation for me to introduce it. Sorry for not having it still in Methane Miner.
No worries. Thank you for your answer.
Thank you. Are there any other questions? If not, thank you very much for your attention. And I don't know how can I switch it off, because I don't see. So if you have no question in a chat, there is a link to Google Forms. So please, if you have not applied, this is the last chance before I switch off this meeting to copy somewhere this link. And if you have done so, or if you have already access to the Slack channel, so then see you at the Slack channel. And thank you very much for your attention, and see you next week. So bye-bye.